Central tendency measurement. Summation symbol. We use Greek letter sigma, summation, as a symbol for summation. This symbol represents summation of xi for every value of I equals 1, 2, 3 through n. Thus, summation of xi for every value of I equals x1 plus x2 plus x3 plus all the way through xn. Properties of summation. Let xy be variables and cd be constants. 1. Summation of c. Every value of I equals 1, 2, 3 through n, equals cn. 2. Summation of cxi. Every value of I equals 1, 2, 3 through n, equals c summation of xi for every value of I equals 1, 2, 3 through n. 3. Summation of cxi plus d, every value of I equals c summation of cxi for every value of I through n plus nd. 4. Summation of xi plus yi for every value of I equals 1 through n, equals summation of xi for every value of I equals 1 through n, plus summation yi for every value of I equals 1 through n. 5. Summation of xi minus yi for every value of I equals 1 through n, equals summation of xi for every value of I equals 1 through n, minus summation yi for every value of I equals 1 through n. Central tendency measurements are methods of finding data representation which are 1. Arithmetic means, 2. Median, 3. Mode. Arithmetic mean, symbol as shown, represents arithmetic mean. 1. Mean of undistributed data. Given that x1, x2 through xn represent data 1, 2 through n, respectively, in n represents total number of data, we get formula. X bar equals x1 plus x2 plus through plus xn over n. X bar equals summation of xi for every value 1 through n over n equals summation of x over n. Weighted arithmetic mean. Given W1, W2, W3 through Wk are weights of importance of data x1, x2, x3 through xk respectively, we get formula x bar equals W1 x1 plus W2 x2 plus through plus Wk xk over W1 plus W2 plus through plus Wk. X bar equals summation of Wi xi for every value of I equals 1 through k over summation of Wi for every value of I equals 1 through k. When x1 represents value of I data, W1 represents weight of I data, k represent total number of data. Combined mean, given x bar 1, x bar 2, x bar 3 through x bar k are mean of each data set, and n1, n2, n3 through nk are total numbers of each data. Formula. X bar total equals n1 x bar 1 plus n2 x bar 2 plus through plus nk x bar k over n1 plus n2 plus through plus nk. X bar total equals summation ni x bar I for every value of 1 through k over summation ni for every value of 1 through k. 2. Arithmetic mean of distributed data. Given f1, f2, f3 through fk are frequencies of data, and x1, x2, x3 through xk are middle points of each class interval, and k is number of class, then we get x bar equals f1, x1 plus f2, x2 plus through plus fk, xk over f1 plus f2 plus through plus fk, or x bar equals summation of fi, xi, I for every value of I, 1 through k, over summation fi, I for every value of 1 through k. Properties arithmetic mean. 1. Multiplication of arithmetic mean and total numbers of data equals to summation of all data. That is, x bar equals summation xi for every value of 1 through n over n, then summation of xi for every value of 1 through n equals nx bar. 2. Summation of square of the differences between mean and each data is always equal to 0. That is, summation of xi minus x bar squared for every value of 1 through n equals 0. 3. Summation of square of differences between each data and some values will be the least given that value equals to arithmetic mean. That is, summation of xi minus a squared for every value of 1 through n is the least when a equals x bar. 4. Arithmetic of each data set is between minimum and maximum of its data set. That is, x min less than x bar less than x max. Notice, 1. If we add or subtract each data with constant arithmetic mean of new data set will equal to previous arithmetic mean plus or minus with that constant. That is, x bar new equals x bar previous plus or minus c. c is constant. 2. If we multiply or divide each data with constant arithmetic mean of new data set will equal to previous arithmetic mean multiply or divide with that constant. That is, x bar new equals c x bar previous. c is constant. Or x bar new equals 1 over c x bar previous. c is constant. Median. Median is data located in the center of data set which arranged in ascending or descending order. The symbol med or me represents median. 1. Median of undistributed data has the following procedures. 1. Arrange data in ascending or descending order. 2. Find median location from n plus 1 over 2. Median is data at n plus 1 over 2 location when n is total numbers of data. 2. Median of distributed data. Methods of finding median are as follows. 1. Cumulative frequency. 2. Find median location from n over 2. 3. Find L, I, Fm, and summation FL, then substitute into formula. Median equals L plus I, n over 2, minus summation FL over Fm. When L represents lower boundary of class interval with median, called median class. I represents interval of median class. Fm represent frequency of median class. Summation FL represent cumulative frequency before median class. N represents total number of data. Mode. Mode is data with highest frequency or the most repeated data. There can be one, more than one, or even none mode for each data set. Symbol mo represents mode. 1. Mode of undistributed data. Mode can be considered from the most repeated data. 2. Mode of distributed data can be done as follows. 1. Find class interval with the most frequency. This class called mode class. 2. Find L, I, D1, D2. 3. Substitute into formula. Mode equals L plus I, D1 over D1 plus D2. When L is lower boundary of the highest frequency class, mode class. I is interval, D1 is frequency difference between mode class and lower class. D2 is frequency difference between mode class and upper class. Vocabulary: qualitative, tabular, pictogram, boundary, cumulative, tendency, descend. Relationship between central tendencies. For data that has frequency distribution similar to normal curve, we can estimate relationship between mean, median, and mode as follows. X bar minus mode equals 3 X bar minus median. Notices of principles for central tendencies. 1. Arithmetic mean acquired from every data, while median and mode only acquired from some data. 2. If some data are too high or too low, these data will affect arithmetic mean but will not affect median and mode. 3. If there is any open class and frequency distribution table, we can't find mean, but we can still find median and mode. 4. Median mode can be found from the cumulative frequency curve, ogive, and histogram respectively. 5. We can only find the mode for qualitative data.